See, that's what I thought too, but I didn't hear it from Nathan. No, I was
Good. It's a good reputation to have. But then you have me, and then you realize I'm not so scary. Sean said this. I believe it. He said, Nathan said mean things about you. I said you terrible things about you. All right. If something is symmetric on the x-axis, remember that the x stays the same and the y changes. So x stays the same, y changes. And if it's symmetric with the y-axis, for every xy on the graph, negative xy is on the graph, right? And what happens with the origin? They both change. This is important when we're trying to do this without graphing it, because that's what the goal of today's homework is. And basically, you just want to check when you plug in these things, do you get back the original problem? But you got to know what you're looking for when you do this. So let's look at a few of these and see what we can figure out. I printed them out for myself. What do you think about that? And I actually worked them out like I do in my other classes. Like in pre-calculus and calculus, like I make the notes and then I work out all the examples. But in this class, I just wing it because it's called algebra. Algebra 2, I just wing it. ECA Live, I just wing it. But in this class, like it's all, but yesterday I just wanted to make sure I was good on my answers with my symmetry. Since Sylvia tripped me up yesterday with her question. And I hadn't really worked it out, so I decided I better work it out today and be prepared. I know, I have to be prepared. So I actually took this home last night and I worked it out. I even worked out a couple homework problems, but then I realized they were pretty simple and I didn't need to work them out, but I did anyway. So, the homework today, most of it says state the intercepts, which we've been doing, and also test for symmetry. And I don't know about you, but I don't want to graph this equation. So we want to be able to test for symmetry algebraically. But the intercept part, that's nothing new, right? So for the intercepts, we're just going to plug in 0 for one and solve for the other. So which one do you want to plug in 0 for first, x or y? That'd be the easiest one, right? So if I plug in 0 for x, I'm going to get 0 over 0 plus 1, or that's just going to be a y-intercept of 0. Because I'm finding the intercept, right? So the intercept means I plug in 0 for x, right? Like I could really write it like this. Right? So, but it's 0 divided by 1, right? Okay. Because 0, if it's 0 on top, then it's all just 0. If I plug in 0 for y, I get 0 equals 4x squared over x squared plus 1. How do I solve that? Put 0 in for x. You would get 0. Right, and it really works out like that one because there's nothing at the top. But when you see a fraction like this and you're trying to solve it equal to 0, technically speaking, could we multiply both sides by x squared plus 1? Like if I multiply this side by x squared plus 1, it cancels out. And if I multiply the other side by x squared plus 1, it's, yeah, you still just get 0, because 0 times anything is 0. So Taylor, you get the right answer on this one. You're not going to plug in 0 for x. But to solve this, do you agree it's just going to be 0? Because you can divide by 4, you still get 0. You can take the square root of 0. You still get 0. At any point when you realize it's 0, you can stop that, but I was just showing the algebra part there. So on this one, the x and the y-intercept happen to both be 0. All right, so that's what we've been doing, but maybe a little more work today. Test for symmetry. When you're going to test for symmetry, you want to find out when I plug in these things that are x-axis, y-axis, and origin, do I get back the same thing? So I'm going to kind of show a lot of work on this one, and then as we go, you might be able to say, I can figure this out without actually doing it every time. But for the x-axis, remember, it's what? The x stays the same, but the y changes. So my question is if we plug in x for x and negative y for y, do we get back the same thing that we started with? If I plug in negative y for y, I get negative y equals 4x squared over x squared plus 1. You with me on that? This side stayed the same, right? Did this side stay the same? So since it did not stay exactly the same, we would say that this is not symmetric with the x-axis. Let's get to one that is symmetric so you can see what I'm talking about on this before you get, I know, just hold tight for just 1 minute. Let's try the y-axis, and then we'll see if we're still confused. The y-axis, we plug in negative x, y, right? That's the y-axis. It flips over, x changes, y stays the same. So now let's go through and plug in negative x everywhere we see x. Let's leave y as y and see if we get back what we started with. So y stays y, but 4 times negative x squared over negative x squared plus 1. Because what is negative x squared? And what, yeah, so it just really stays exactly the same because when you square negative, nothing changes, right? So if you get back the exact same thing that you started with, we would say, yes, it's symmetric with the y-axis. No to the x-axis because we didn't get back the same thing. And you can probably start seeing, if you have an even exponent and you plug in a negative, do you agree it's always going to stay the same? But if it's not an even exponent, it's not going to stay the same. So some people don't really show a lot of work on this because they just say, well, for the origin, what's going to happen if I change both signs on the x and the y? Am I going to get back what I started with? No, because the x will stay the same, but the y won't. And so we can say no to that one without actually working it out. Does that make a little bit of sense of what we're doing there? Okay. So it's a little more algebra to do, but it makes us not have to graph this big ugly equation, which we don't want to graph yet. So let's do a couple more. Not, yes, I said yes.
Today or tomorrow?
Not anytime soon, but eventually in this book we will. Maybe in chapter 3. No, not really. I think there's on your homework that make you, like, they give you part of a graph and they say complete the graph if it's symmetric in the x-axis or something. That's easy. Tomorrow we're doing slope. Point slope form, slope intercept form, find the equation of a line that's parallel to this line, write an equation that's... I know, I got excited about slope, but I was off. It wasn't even this section. But tomorrow, I promise, you get to learn slope. Same directions on this. X-axis, y-axis, origin. So I'm going to give you a head start here. I'll write up here, like for the x-axis, it's x negative y. And for the y-axis, it's negative xy. And for the origin, it's negative x, negative y. And again, some people are really good at just looking at it and knowing, and I'm fine with that. But if you want to actually plug it in every time, you can do that as well. But you're looking to see, do I get back the same thing that I started with? I'll actually show a little work here. So what do you think for the x-axis? Is it symmetric? Yeah, because when you plug negative y into something that's squared, it is going to turn out to be the exact same thing. So, like, I usually just write x-axis, and then I write yes or no, and so then I'm going to say yes. If you don't really show any work and you just want to write which ones are symmetric with it, I'm okay with that too. What about the y-axis? When I plug in a negative for x, do I get back the same thing? No, the negative stays in there, doesn't go away, so it's not symmetric with the y-axis. What about the origin? Sometimes it can have more than one symmetry. Think about the ones on your graph that you did on your homework yesterday, and our notes yesterday. Sometimes it's symmetric with both the x-axis and the origin, or the y-axis and the x-axis. So it is important that you check all of them, even if you get one to work. It also could be symmetric with none of them, which can happen. I think we're also supposed to find intercepts on this.
Yeah.
So to find my y-intercept, I'm going to make x 0, so that's going to be y squared equals 9. square root, I would get plus or minus 3. That kind of makes sense that it's symmetric with the x-axis if you have two y-intercepts because it's going to flip over. And x would be 0 equals x plus 9. So is that just negative 9 equals x? Okay with that? Let's do one more of these. No, then I got a couple more things. Only 2 more slides after this one. No. 3 if you count. 3 if you count that one. I don't get that count. Tucker wrote some problems on the board for you guys to figure out today. Over here. It's Nate.
Where?
The very, oh, I thought you were talking about the bottom one.
Well, that one too.
Struggles with his 8s.
Is it a 7 or is it not? 5 by 6.
The one with the eraser mark, that's a 5. It was a little rough. I'm not really sure what happened.
Yeah, it almost looks like a 7.
Something.
It's like a 7.
Oh yes, make an S and close the gate is what he always says for me. Because he struggles with his 8s, as you can see. But yeah, he always tries to sing them, and then I sing them, and he's like, that's not right. That's not right. Don't do it the right way. I'll do my intercepts first. Because I say, like, it goes to, like, skip to my loop. So then it ends with, like, that's how you make the number 5. But he says it's numeral 5, and I always say number 5, and apparently it's not okay to say number when it says numeral. Who teaches kindergartners to say numeral, really? So I just don't sing the song anymore. He did make his 4s like this before kindergarten started. Like, he always made them like this. I don't know why he started doing that, but I guess just because he sees them printed like this. And they're like, you have to stop making your 4s like that because you're going to get in trouble in kindergarten.
Why?
Because they make you make them like that.
Yeah.
They don't like you.
And like the 2s, I always like make a curve.
Yeah, like I always make my 2s like this. That is not okay in kindergarten. Like, you cannot make a loop.
Why not? That one looks like a kindergarten shrub.
I know, right? Because after a while, you kind of make your own style too, right?
Yeah, I don't make it to lose.
Yeah, I make it loop.
How do you find the x-intercepts on this? 0 equals x squared minus 3x minus 4.
Hey, I just factored.
You can just factor, complete the square, do the quadratic formula.
Hey,
Hey,
I just factored.
I just factored. Minus 4 plus 1.
Hey, boo-boo.
X equals 4, x equals negative 1. What about the symmetry on these? Alright, I'm ready. The big thing is when we have our quiz in here, when we have the unit test in here, you have to make sure you know which one's negative. And again, I don't ever really memorize it. Like when I'm writing this on the board, I think in my head, x-axis, which one changes? Oh, the y changes. Y-axis, oh, the x changes. So just visualize what it is, and then you don't really have to feel like you're memorizing it. Because if we plug the negative y in, it's still going to be negative, so that's a no. And the negative x, this one stays the same, but this one doesn't go away, right? Like that's going to stay negative, and so it's not going to go away either. And the origin is just a big mess also. No. So this is an example that has no symmetry. Okay, so just don't be thrown off by that if you get that on your homework. All right, what else is in this section? There are 3 graphs that they say you should know about and be aware of because they show up sometimes. So let's talk about them and some properties of them. In chapter 3, there's a section called a library of functions, which is like 10 basic functions that you should know. But today it's like pre-calculus. I love library of functions. Like I always say, like in your head, you should have that little file folder that has just all these functions you should know about. Like on SpongeBob when he goes to 5th grade and he has all those file cabinets.
I wish I had that.
Why would you tell me SpongeBob though? kind of, I don't know, it's kind of a stretch there. Like a stretch out S. I just think sorry, I humor myself. But if you graph this, think about if you plug 0 in here, what are you going to get? 0. If you plug 1 in here, what are you going to get?
1.
If you plug negative 1 in here, what are you going to get?
Negative 1.
If you plug 2 in here, what are you going to get?
8.
2 to the third is 8, which is why I made 8 little marks on my graph.
So I did.
And if I put negative 2 in there, I'm going to get negative 8. It's okay if you did it. Just kind of go off your graph. But a cubic graph gets big really quickly. What's 3 to the third? 27. So I'm not going to make that one, but it goes up pretty quickly. Like this. So I kind of say like it's like an S, but it's really just like a stretched out S. And it's going the wrong way. What would this be symmetric with? What kind of symmetry does it have? Symmetric with the origin, because for every positive point you have the same negative point down here. What would the intercepts be on this graph? Yeah, it only crosses at 0, 0, so we could say it has intercepts at 0, 0. So you should just kind of vaguely be aware of that for now. You should. What about this one? X equals y squared. I feel like that was a weird one to throw in there because most of the time we think y equals x squared is a parabola, right? What about this? Do you know what this looks like? X equals y squared? What's its name? I don't have a name for it. It's not a straight line. It's tricky. Square. Because x is first and y is squared, when we pick these, we actually pick x's first and plug them in for y's. How about that for weird? It is a parabola, but it's just a tricky parabola. What happens if I plug 0 in here? I get 0. What happens if I plug 1 in for x? Oh wait, I'm totally doing this wrong. I should be picking y's.
I was wondering what you were doing.
If I plug 1 for y, I get 1 for x. You with me on that? If I plug in negative 1 for y, what do I get for x? Still 1. So the x repeats itself, not the y's, and so some people figured it out already, that you get a sideways parabola. If you plug in plus or minus 2 for y, what would you get for x? If you plug in 2 for y, what do you get for x? 2 squared is 4. If you plug in negative 2, you're also going to get 4. So at 4 and 2, it looks like this. So it's a sideways parabola. We did those in Algebra 2, conic sections. We did it in pre-cal, or we will do it in pre-cal if you're in pre-cal now. It is still a parabola. It's just a sideways parabola, right? So if you want to call it a parabola, you can. What symmetry does this have? They don't include y equals x squared because they assume that you all know what that one looks like. It starts at 0, 0 and is a parabola opening up. It's symmetric with the y-axis, but they assume that you got that one down. What about the intercept on this one? Still at 0, 0. And then the last one that they throw in that you should know is 1 over x. This is the reciprocal function because it's x flipped over. You know what this one looks like? Oh my goodness, boys that are in pre-calculus, we're talking about this function today in pre-calculus. Bryce, why are you sleeping?
Sit down, aren't you guys recording?
Not really.
I won't let it get ever.
1 over x. What's the problem with this one? What could I not have as an x value on this one? 0, which means I'm going to have an asymptote on this graph. So like I can show that with like a little dotted line here. Like it's never going to actually touch the y-axis, and it's also actually never going to touch the x-axis. And so when you pick points on this one, oh, it's all messed up. Why did I change from black on my graphic? Red. I just picked red instead of black, and now I have to use blue, and I'm just all messed up with my colors.
You like blue too?
Why do you have to?
I just like them all to be the same.
Why is it limited to 4 colors?
It's really not limited to 4 colors. I can add whatever color I want. It's just this. See, look. Oh my gosh, we don't have time for this today, but like I could click this, and I could make it any.
All those colors.
Yes.
I ever use just
Because I have to do this every time.
Use red. I mean, not red, blue. Yeah,
If you pick one, so you can't even really tell.
blue's better. Blue.
I already have blue.
or ...
Because you can pick, you can make whatever you want. See?
See, that is odd. You just gotta like raise it up a little bit so it's lighter.
And you have
And then like black.
pumpkin. And it's.
Yeah, it's October. We should use them.
Okay. If I plug 1 in here, I get 1. If I plug 2 in here, I get 1/2. If I plug 3 in here, I get 1/3. Right? We get a bunch of fractions. So when you plug these in here, they keep getting closer and closer to that x-axis, but they never actually get there. So it comes down and looks like this. If you pick fractions, it's going to flip it over. So like if you pick 1/2, it's going to actually go up to 2. If you pick 1/3, it's going to go up to 3. And so they make these little, we call them L shapes. I don't really know that they're L's, but they follow the asymptotes, right? Any vague memories of that from Algebra 2 and or pre-calculus? And you have another half over here. If you plug in negative x's, you're going to get negative y's. And so you're going to get that same shape going like this. We'll talk more about these when we get into the fact that you actually have to graph them, but they just want you to be aware of them. What kind of symmetry does this have? And it has no intercepts. It doesn't touch the x or the y axis. Okay? Oh, I got one more. 2 more slides. This is only 1 more slide. There's just a lot on it. Quit complaining. It's not like you started your homework when I gave you anything.
I did. I did my homework in class yesterday. All of it.
There's a couple questions at the end of your homework like this, and I just want to make sure you know how to do it. I'm going to pick a new color.
Purple.
I should do orange.
Pink. Orange back, yes. Pink.
Pink's not even going to show up.
Oh, those dark.
Not that thing, but just do it.
Little more.
I don't have time for that.
Color over there.
Over here. I want orange.
That doesn't even look orange. That's not orange.
It is orange. My screen is just awful.
I'm sure on there it's definite color in the computer.
Yeah. What about this? It says if negative 2b is a point on the graph of 2x plus 3y equals 2. What is b? Do you know how to do that?
Plug it in, or
This is an x and a y, right? So can you just plug in negative 2 for x and b for y and solve that problem? That's not so bad, right? I just want to make sure you knew how to do it. Well, I mean, whatever you get, your answer is b, right? You could leave this. I left it as y in my problem, but then I got y equals a number, and I felt weird because it should be b equals a number. So then I just changed it to b. So I would say 2 times negative 2 plus 3b equals 2. Negative 4 plus 3b equals 2. Add 4. 3b equals 6. B equals 2. Yes, no, maybe? Yeah. Nathan. Everybody okay with that? Here's your homework. Seems like kind of a lot. It's really not that bad. But 52, 54, and then 57 through 69 multiples of 3. 71 through 75. 77, 81, 82. I think that's like 14 problems. Some of them are easy. But, well, actually,